So I got that ready and that ready. Okay, first thing we're gonna look at is the example that was in our book that we did at the end last time. Let's see if I can. And then we're gonna look. I think I have that one. Oh, I thought I also had that one in JavaScript. I'll look here in just a minute. Okay, let me go back here. Where we left off was, okay, we stopped on page 212. And so first of all, I'm going to go over, just review a second this PowerPoint slide that was what we did. Oops, it's way back up here. I think it was slide 10. So since it was over the weekend, we probably, oops, no, it must be this one. Yeah, this one. And then we're going to look at the HTML to make this function work, or the JavaScript. So this was at the top, well, it actually started over on page 211, where we talked about this terms and terminology, and we talked about modularizing. And display address info is a method that it shows us in figure 213, full name billing program dot display address info. Only use the full name when it's called in another class. So you never have to use this part of it unless there's a program that calls it in another and calls that class. So statements contained in a method are said to be encapsulated. So all the statements that are inside on page 213, the display address info function, all of those statements are said to be encapsulated. So even in a main section, or in a main class in that part of the program, main is what we always use to say start, right? We did it instead of main. But main is actually a function also. It's the main function. It's the one that executes or calls all the others. And so all the statements inside the main are said to be encapsulated. So breaking a program into methods, it requires experience. There's no specific rules to follow. But I'm going to show you a couple of little examples that it's pretty easy to see why it would be good to split them into methods. Functional cohesion refers to the extent to which a method's statements are focused on the single specific method task. Because what does cohesion mean? It means sticking together, right? If something's cohesive, it sticks together. So it's saying when you create a function, you want to be sure that all the statements inside there actually stick to what that function is supposed to do, not do several other functions within that one. And that's what it means by functional cohesion, that it all sticks together. Okay, so this next part that you had to do a little bit of reading on your own to understand how to do 1B, declaring variables and constants within methods. Any statements can be included in methods. They can be input statements, processing statements, output, anything that we've been including in a program, even declarations. All of those can be inside a method. There's no limitations to only loops can be in a method or only decision statements. Anything that can be in the main method that we've been coding can also be in the smaller functions or methods. Okay, so over on page 213, we talk about variables and constants that are declared within a method. They are usable only within that method. And we talked about this a few minutes at the end of class. They are considered local, in scope, or visible. So everything that you declare inside the main is only visible inside that main function. So all our declarations that we make at the top of our main, that's the only place that they're in scope or that they're visible. They go out of scope or cease to exist when the method ends. So if we're right here, display address information, well, when we go over to that function, display address information, we do not see name or balance because those were actually declared in the main section. Input and name, this is figure 6-3. All of these that were declared above cannot be seen once it goes over here, all right? So we don't know anything about the name and balance. We're just going to display the address information. Those are the things that are in scope, and these declarations, by the same token, line 1, line 2, line 3 are not known inside main because their scope is only inside this one function. Any questions about that? Is that foggy to anyone? Little bit. Ask if you have a question, let me know, because these are ones that we're not using. But see, we don't need name and balance inside display address info, do we? We don't need name and balance. We don't need lines 1, 2, and 3 over here either inside main because we're displaying this inside this function. All right, so I have over then on, what page is this one? Local main variables. Okay, this part is over at the top of page 214. Variables and constants declared within main. Well, part of this is still about on 213. Cannot be used in method. Global variables are accessible to the entire class. Now, we're not going to deal with global variables in this class, and I don't, it's kind of redundant there. This whole semester, we're not going to deal with global variables. You will do that when you take a programming language like Java or C++, okay? That's in Chapter 7, and we're not going to get to that one. Okay, so when methods must share data, there is a way for the main to share data with another function or method, okay, without using global variables. There's a way to do that. You can pass data into and return data from a method. When calling a method, here's what you must know. You must have the name of the method, which means that in JavaScript, it'll be a function name, okay? But that's just because JavaScript, Java, C++, that's what they call a method, is a function, okay? What type of information to send to the method, if any. What type of return data to expect from the method. Those are the things that you have to know when you call a method. So what does it mean by calling a method? Where do you do that from? Inside what? In the main. Very good. So inside the main, our whole goal here in modularizing is to make the main smaller and smaller, okay, and pull the functions out so that inside the main is just the general that's going on. And so that's our whole goal here, is see our main may have been this long and we want to shorten it and pull the functions that we can out into separate functions, okay? So the calling, in order to call a method, you have to know the name of it, if it needs information from the main, and then what type it's going to return back to the main, what type of data, if any. Okay, so over on, still on page 214, creating methods that require parameters. An argument is a data item that is passed into a method from a calling program. So some people call those other names too. Sometimes it tells you here they're called what else did it call them? Argument and parameter are closely related terms, but normally it's called an argument that's coming from the main and going into the method or function, okay? So if you are passing data that you've asked the user to input inside the main, then you can pass it, and that's what we're going to see how to do. A parameter is what the method receives, the argument into a parameter. That's why when we looked at that one last week, that the name that it was called in main was different than the name that you see in the function, because it's passing it into a parameter, but their variable names cannot be the same. Causes you problems, okay? It won't give you an error, but it will give you a logic error. Okay, argument and parameter. Closely related terms, calling method sends an argument to a called method. Called method accepts the value as its parameter. Okay, so parameters are inside the parentheses of where the function is defined. Okay, and argument is inside the line in main where the argument is called, or I'm sorry, the function is called. Okay, so we're going to see some examples of that here in just a second. So creating methods, let me see something. I think I was going to show you, first of all, I'm going to show you this example. I want to see if this is the one. Wait, let me see if this is the one that does that. Okay, so yeah, we're going to, let me look at this one that I've already got in JavaScript. Oops. Okay, this one does not pass anything. This is the one that is the on page 213, where we're not passing anything into display information info. This is the function in JavaScript. Let me see, I was going to move that over. Let's see if I can do that. No, that wasn't what I wanted. Text. Show toolbar. I remember now. Hide files. Okay, so with this, what we're doing is we've written our, here's our script. This is where you start. There's the where's this one at? Okay, variable break. So I've defined a break. Function, display address information. So here's the function. This is what is on page 213, which has variable line 1, variable line 2, variable line 3, right? So this is the function. We haven't started the program yet. This is the function, or we haven't started the main yet, I should say. Most of the time in most languages, the functions are defined above where the main starts. So the browser is actually not even looking at the function until it gets down here and sees display address info. That's the call to this. And it knows to go up here, execute this, then come back down and directly below where it went out of main to get here. Okay? So what it does is it says variable name, variable balance, name equals prompt, enter name, prompt, enter balance, balance equals 1.0 times balance, then display address info, document.writeLine customer total. So let's see if this runs. Where did my, there it is. Enter name, enter balance, and there it is. So it went through and printed out the address, the customer, and the balance, right? So it would have done it the other way too without the method, but this way the method, it's making the main shorter, not as long, so that it can, and I'll put all these in Evernote and we'll get yours fixed, Kat, where you can. Did it work? Oh, good. Okay, so that's what it was. All right, so anybody have any questions?
Could you go into that? Yeah.
Now you notice there is one thing different. The script is inside the body. Did y'all notice that? Where was our script before? Up above the head, in the head section. That's because we're using functions. Okay. So, but I'll save this for you. You won't have to type it all in right now. But any questions about that? This function, we can have as many functions up here above the main section, and it will just execute them only if they're called. So if this line was commented out, let me save it. Oh, I'm not getting to see my file. Save as, I'm going to call this figure 3-1. Okay, so if I was to save it like that, then execute it, why did that happen? Function was there. Display address info was there. But look, in my main, I commented the call out. So it just totally ignored that this was there, right? So it didn't know to execute function unless in the main you call it. It doesn't say call display address info. It just knows that it's a function because of the parentheses there. Okay.
What can you put in the parentheses of a function?
That's what we're going to do next. Okay. That's where we put the arguments that we are going to pass data into there. Okay, so if we wanted to pass name into here, we could actually do that, and that's what we'll see next. We've got another one that we're gonna do. Okay, so here we go. Creating methods that require parameters. For example, we're going to modify display address info method to display a message preceding the name and address on the bill if the balance is over $1,000. There are 4 approaches to modifying the method, and those are listed in your book on page 215. Rewrite the program to eliminate the display address info method and place all statements within main. But just like it says, making the main method more streamlined and abstract is our goal. That's what modularizing is. So if we go back and we just put all of those statements back in main and add the message, it will work, but we've defeated what we were trying to do, modularize, right? So that's not a good approach. We can retain the display address info method, but make the balance variable global by declaring it outside any methods. The problem with global variables, you would lose some of the portability. Portability, you remember it was talked about earlier in the chapter. I don't think I did mention it today, but what makes a method portable is if you don't have to have a specific name of a variable in order to get it to if you don't have to have a specific name, then it is not portable. Then it is portable. It's not portable if you have to have a specific global variable that is named in the main. Then that would mean if it was global, it would have to be the same wherever it was used. Okay, so that's not a good method. Okay, let's go to, I'm going to tell him that I'm in class real quick. Somebody that my daughter needs to get a hold of. Let's see. Okay, so the next one that we want to look at in the 4 approaches is the third one. Says retain the display address info method, add a local variable to display address info, and prompt the user for the balance again within the method. Okay, so they're saying there, so what's wrong with that? Why is that not a good way to do it? Why would that not be a good way? It would work, but it tells you right on page 215, the disadvantage to this approach is that the user must answer a balance question twice during one execution of the program. Okay, so if you don't find a way to pass the balance into the method, then you have to ask them again for the method. For the balance, right? Okay, so let's, oops, my things went whack, didn't it? Where did that go? Okay, there it is. Okay, so the last one says store the variable that holds the balance in main so it can be used to display the customer's balance and pass the balance to the display address info method. It's the best choice. Oh my goodness. So we can see figure 6-4 on the next slide. 6-4. Okay, I bet I'm going to have to, I'll pause this just to that down. Okay, so we want to look back at 6.4 then, and make sure that's still. And in 6.4, let's back up. I think I have that on a slide. Yeah, here it is. Okay, in 6.4, what we've done is we have taken, if you look either at the pseudocode, and you won't be able to see that up on the screen. Let me see here. So be sure you're looking in your book on 2:16 and 2:17 because you won't be able to see way back there what I'm talking about. But in the pseudocode, where it calls display address info, you notice it has for the argument, it has the name that you took it in, that variable balance, right? So the argument must be the balance, which is input name and balance. So in our program, that's our prompts, right? So that variable name that you pass as the argument has to be what's in parentheses in the call. Does everybody understand that? But then when it actually calls display address info, you notice it's got another name that says amount due, because it's the parameter that it's going into, and the word or the variable name balance is not known inside the actual function here. You see in the flow chart, maybe that's easier to see. It goes from balance into amount due, and it has to be a different name inside the function because the function doesn't know it here. And actually in JavaScript, we go in, see right here where it declares it? It doesn't have a declaration inside the function, but it says num amount due in the parameter.
It's the same variable?
It's the same value, but it's not the same memory address, which is called the reference. Remember when I talked early on in the semester how the computer stores things, but we don't have to know the memory addresses, but it's actually putting a copy of it into amount due, okay? Because inside display address info doesn't know what balance is. But if I say take that argument, what's inside balance, and put it into amount due, that's what it's doing. Oops. Anybody else have a question? Some puzzled look, some's a little foggy. Yes.
I have been having some trouble trying to code my 1B. I got it to run, but that's because I declared the one function inside the other function. So when I drag it outside, for some reason, it won't calculate right.
Okay, well, we'll look at that. Let's see how this one, because I think I have this one where we're passing, and I know I've got a couple other examples.
It won't pass the variables to the other
the other functions. Okay, well, we'll look at it and see what's going on. Okay, so this one is how it would look when it runs. This shows sample output from the billing application. So in this one, this is actually at the bottom of page 217. Prompts are added for customer data, and then the program is executed in a command line environment. So this is what they want to happen. Enter the customer name, enter the customer balance. This bill requires immediate attention, which means that their balance was, what did it say it needed to be? If amount due is greater than limit, which limit is defined as 1,000, and it is greater than limit. So that's why it printed out the message there. Now, I've got another one that I'll show you here in just a second, and it will answer that, I think. Okay, here's what we want to do next is we want to be able to create a method that requires a single parameter is what we looked at. So a method can receive a parameter, must include the following information in the header's parentheses. And that's what we just saw, the type of parameter. So when it receives it, what was the type up here that it told us it was? Number, because it said num amount due. So it gave us the type. And then it gave us the local name for the parameter, which was amount due, because that's local to this function. Okay? Okay, passing arguments by, oops, where'd that go? Oh, what'd I do here? I think I'm not jumping right. I went too far. Okay. My thing go. There it is. Okay. So before we do that, before we go to the next one, which is passing by reference, where did I put that? Where? I'm just going to show you that. Make sure that it makes sense where I'm through all of that. Oh, I must have skipped it. Yeah, okay. So I'm going to show you another example that we're going to look at some that were created. Come on. Okay. Review. Okay, this one is where we did those problems where we squared a number. Do you remember when we did that? Okay, so this one is just a program that executes without a module, without a function. Variable number, variable square, number equals prompt, enter a number, type here, then square the number and write out the number. Okay, so this one was the one that we have seen run before. Okay, now we're going to look at that same problem only with a function, and that function is going to pass a number. Okay, so here it is, variable break equals break, function get square, this is the name of the function, pass it into number, and down here it's called num, right? So this is the argument that's going to be passed when it's called here. It says square SQ equals. Now, you'll notice the difference. When we did display address info, there was no variable on this side. Why? You know what I'm talking about? When I called display address info, that's all it said there. Why can't I just say get square num and leave this part off? Why is that important? Anybody know? Why is that important? Why do I have to have this SQ? It's a variable up here. Why do I need it? What would happen if I just said get square num and I go up here, I pass num into number, and then I have variable SQR. SQR equals number times number, and then it says return SQR. So it's going to return it, but where does it return it to if I don't have that? If I don't have that, it doesn't have any place to put it in the main, right? Not make sense? Okay, so if well, let's run it and let's see how it works, and then I'll take that out and show you. Okay, with square. Okay, enter a number. Let's say enter 4, and there's my square, right? 16. Okay, now what if I go over here and I take this off and say file save, and I run it. Square's undefined, right? Because I did not have anything to return it to. It returned it to here, but there was nothing there to put, no memory location to put it in. Oops, that's not right. SQ, right? Then I also have a second function that printed it, right? So instead of saying document.writeLine down here, I said function print. So this called the SQ. It sent this argument here, but I didn't have to return anything. Why not? In the print function, I didn't have to return anything. Because right here, I'm printing it out inside the function, right? So I don't need to send anything back. I'm just saying, go to my print function, take this variable as an argument, put it in this parameter, right? And then use what's in there to write out. So I took everything out of my main that was any kind of a task, and I put it in two separate functions. Now, I could have put this inside here, but then that kind of takes away from the functional cohesiveness, okay? But that, again, is just kind of personal preference because, you know, people get used to, if it's a function, they maybe don't want a separate print function. They wanted it inside here. Or they wanted to come back here and pass it back and print it out here, okay? This is just to show you how simple functions work. There's a print function, and there's a function to get the square of a number. I can't tell. We got it. Did you get yours to work?
Yes, finally.
Okay. You got hers to work. All right. So, any questions about that? I'll put all these in there for y'all to ponder over, okay?
Stare at.
Yes, Kalia.
Is SQ a specific thing? Like we can say bar, like bar AS, like use different letters to
Oh, you could use different letters. That's just a variable name. These are just, as a matter of fact, oh, I'm going to do one time. Okay, so any of these are variable names. You can use any letters you want. That there is a function that finds a square root that's already a predefined function. We'll talk about those later. But this is just a variable. So anything you want it to be. Any other questions? Yes.
The function print, it's just like it gets whatever is, because we only have one function, right?
This is a function, get square, and print's a function.
Okay, so you name it a param, right?
No, that's the parameter.
The parameter, okay.
See, like print, it's the argument is SQ, but SQ is not known in the function. So it's like in your book where it drew an arrow from, or a connecting line from here to here.
Okay.
All right.
Okay.
All right. Print, param. Now the one thing that it did not do here, because it sometimes it'll know it's a number. I guess you could have put bar param there and bar number, but JavaScript doesn't require that. Okay, it just knows what data type it is when it comes in there. But in our pseudocode, we did do that. So you follow what I'm saying. We did do that, but it's not required in the JavaScript. Okay. Yes.
Is print the same as document.writeline?
No. In this case, like we could have called this print out or whatever we want to call it, as long as it's the same name up here. In this case, it's the same as document.writeline because that's what it does, just a document.writeline. But this is just saying, I want to have a function that will print my variable. So we just made that up, okay, that name print, because it's like, so I could name that function anything I want to name it here. Just so I name it here and here the same. So when I call it, it's the same. Okay? All right, anybody else? Okay, so let's look at also Chapter 6 3a. I'm going to give this to you, and I know Amelia already has 3b, I guess. So here is... Oh, wait a minute. It didn't ask for functions, did it? This may be a little more than what 3a asked. Go back here. Oops, all my stickies are... All right, so it said to create the logic for a program that... Oh, this isn't the right program for 3a. No, this is just another sample one that I can show you. Chapter 6 Oh, 3a. It may be 3a. I was thinking 1a. Oh, yeah, it is. Okay, this is the one for 3a, which is kind of like squaring functions. Here's two functions, one that does the sum, one that does the difference. And here's all the comments that tell you what it does. So if you want to test the code, you can test it with 10 and 5 and the product with 10 and 5. So what the program actually does is takes in number 1, number 2, mult. So here it's prompting for enter first number, prompting for the second number, and then it's going to execute the function sum, and actually the product's not in there. I'm going to add it. Here's the sum, and here's the difference. So it's passing these as arguments into the function, which the parameters are called num1, num2, and they went ahead and printed within the function. You could have a separate function that can be called. Okay, now we didn't do the product. Okay, let's execute this one, and then we're going to add something to it. And our first number, let's say, is 10. Okay. Second number is 5. Okay. Sum equals 15, difference equals 5, right? Okay, so let's go and add another function. Let's add one that does the product. So I'm just going to copy this one. Function, let's call this one product num1, num2, and this one is going to be variable. Product is num1 times num2, right? Document doc line would say product, oops, plus equals, oops, okay, so then down here all I need to do is add that work? Oh, here I have another variable. What's that variable for? I don't even know what that variable's in there for. Because this should work. Let's see if it does. File, save. I'm going to go up here. First number's 10. Second number's 5. Worked, right? Anybody have any questions about what we did so far? Okay, so we've got one more type of passing that we're going to talk about. Passing arguments by value is what we've been doing, and by reference, okay? So there's two ways to pass an argument into a method. Pass by value is the copy of the value is sent to the method. And that's what we've been seeing happen. And it's stored in a new memory location, right? So number 1 was passed into num1, right? So it just copied what was taken into a new location. Then there's passed by reference, which is where you pass the address of the original variable and it's sent to the method. A variable in the calling method, can have the same identifier as the parameter in the method header. So the passed variable is a temporary placeholder. A parameter is redeclared with each method execution. So let's see in our book where that is. This is, oh, I'm supposed to be all the way up to 21. Where was that? Oh, okay. That's right there on page 218. So here is figure 6-6 and 6-7, which is on page 219, and it shows an argument being passed by value. It says my val equals 18. They declared it up here. Add 86 past my val, and they passed it into the function 86, and they passed it with the same name. And they passed it by value with the same name. You can do that. It's kind of confusing to do that because then you don't know that you're doing a copy of it. But it does work. All right. Passing arguments by value and by reference. Okay, the one that talk about here, that example that we're seeing on 219 is actually explained at the bottom of 218. Then on page 220, it talks about something called implementation hiding. It's calling a method without understanding the details of how the method works. An important principle of object-oriented programming is the notion of implementation hiding, the encapsulation of method details within a class. With implementation hiding, you make a request to a method without knowing the details of how the method works. For example, when you make a restaurant reservation, you do not need to know how the reservation is actually recorded at the restaurant. Perhaps it is written in a book, marked on a large chalkboard, or entered into a computerized database. The implementation details don't concern you as a patron. And if the restaurant were to change how they did it, you really don't care. You'd still call, give the date, time, what you wanted. You would still do it the same way. The parameter types within parentheses in a method header are the method's parameter list. A method's name and parameter list constitute the method's signature. So right here where it talks about inside the parentheses, that's where you tell it what type you're passing and the name. And that is called the method's signature. Calling method needs to know the method's signature and what type of return data to expect. And that's what we're going to see in this next example. Is passing, that's still passing by value. And now the one that we're going to look at is passing by reference. Here's how you do that. It gives the receiving method address of the original variable. The procedure differs by the programming language. Usually involves placing a special symbol or keyword in the method's header parentheses. Implementation hiding is reduced. We're actually, if you look at this one, num rate, this one is a program that calls a compute tax method that requires two parameters. So that's what this next one, let's look at it. Okay, creating methods that require multiple parameters. That's what the compute tax does. It says you list the arguments within the method call separated by commas, and then you list a data type and local identifier for each parameter within the method headers parentheses, separating the declaration with a comma. Now, not all languages make you do that, but in pseudocode or in figuring out how the logic works, it's usually easier to do that. So pass the arguments in the correct order, and so on 6A shows a method that accepts two parameters, and that's what we see there. Where it's in compute tax, it's going to accept amount and then rate. So it's going to accept them in the exact order that you send in the call. So if you don't put them in the order that you want them, then it won't pick them up that way. Okay, so variable declared within a method ceases to exist when the method ends. So to retain a value, you must return the value to the calling method. And that's what we saw in the square, right? We had to return it. And then we did that in, what was the other one? No, that other one they actually wrote out document.writeLine within the function, so they didn't have to return it, right? So the one that we had to remember that we've seen the example of is the one that was with the square function, because we did the print in a separate function, then we had to return a value, right? We went up here and calculated the square and returned it to this variable SQ, which then used it to print out. Now our other program, this one, we did not return a value back to the main, right? We printed it out each time inside the function, so we did not have to return a value. Do y'all see the difference? Okay, so that's what this next section is about on 222 and 223, is returning a value, which we've already done that. So we've already seen that happen. Now the section that I told y'all to skip is passing an array to a method, and so the only when we come back on Thursday, we're going to cover the section on overloading methods and the one on using predefined methods, which is on 238, and that's the end of this chapter. So what I want you to do, how many of you already got 1B working? Did we get 1B working? Oh, Brittany got it, and you got it, but most of you did not. Okay, so we're going to do 1B. I'm going to give you a chance to try to look at these examples that I've given and make it work. And I've already done 3 and given it to you. I probably better do another one in class, like 4 before. Yeah, can't remember which one that I assigned last semester. Okay, I'll put in Evernote another one for you guys that got 1B working that you can work on, but I'm going to give y'all till next week to get them done, okay? So, oh, my ear's ringing. Ever have that happen? Okay, so if you haven't gotten 1B working, get 1B working, okay? And then we'll go over it. We'll look at some of y'all's that works, okay, on Thursday. I know we stopped a little early, but this is a lot to take in. So I don't want to cover any more of it until y'all get a chance to work with some of these that I've given you. Because there's another example one that I also have here that I'm going to load. That's salary program and a salary program with functions in it. Okay. So I'm going to give you those two also. I'm going to give you what I'll put in Evernote is a zipped file with all these in it that say Chapter 6 examples, okay? And then you can download those out of Evernote. Let's see, it would be, find that, zip it.